All right, well, oil. We all use it, regardless of what you think about it, how we extract it, how we use it, or the world politics behind it. Every one of us uses oil in some way, shape, or form, whether it be directly through driving your car or indirectly from something you got shipped over here from China. Now, the whole world is using the oil, and what that does is it creates a need for it where we have to continue to drill and find more hydrocarbons. And in this article, Challenges for Very Deep Oil and Gas Drilling, World Army at Depth Limit by V.C. Glacidis, he brings up a few challenges that we're facing now as we're tapping we're to the limits of our engineering and we're to the limits of our mechanical abilities to extract and find this oil. So we're just having to go to further reaches of the world. Now, I'm going to start just by explaining a little bit of land drilling. And a traditional conventional well was a simple hole straight into the ground below some hard rock that trapped the oil. And in there, the ground was porous enough to where the oil could flow and you could pump it right out relatively easy. Well, those are the most easily accessible resources of oil, these oil reservoirs. And so as long as we've been using oil, we've been depleting those resources slowly. So our engineering methods and our extraction methods have had to advance with our quickening pace at which we consume the oil as a world as a whole, not just Americans, but everybody else. So one thing, a product of the new engineering has been the ability to directionally drill. And what this has done is let us extract from harder to reach places on land, and you can bore horizontally. So not only are we limited to just drill straight down, we can go horizontally and exploit these oil and gas formations. Now currently our deepest hole in the earth that was ever drilled was the Kola well, K-O-L-A well, and it was drilled in northwest Russia, and it reached about a depth of 7.5 miles, straight vertically down, which, considering most of the oil fields from land are probably between a few thousand feet to about 2 miles deep, that 7.5 mile hole was quite an engineering feat. And the Russians worked on it from about 1979 to 1984, and before they had too many problems, and basically it was the earth fighting back a little too hard and they had to shut down. Well, so these are your conventional land resources or oil availability from land. The problem is a lot of the best resources of oil are offshore. And the problem with that is you've got to drill on top of the ocean. And that poses a whole new set of problems because drilling these land wells, I guess I'm going to step back real quick. This will apply to offshore drilling too, but what we used to drill would take, this is just one pad and I don't remember the field, but anyway, it would take about 32 wells to drill what we can do now with our directional drilling technologies for one well. So basically you do have a lot less surface damage and you use a lot more, or you're a lot more efficient and it's a lot more environmental friendly to do it, to drill that surface damage. But anyway, so using this technology from land, they've transferred that in the oceans. And like I said, unfortunately, it's not as easy to get the ocean, the oil from under the ocean. And with the same problems that you have with pressures and heat and temperature underground and land drilling, you have that in ocean, except now you have a large volume of water you got to set a platform on top of before you start to drill. And first you have all the weather and hurricane possibilities that can easily mess up your rig. But the other thing is, when you can build a platform and mount it on the bottom of the ocean like they traditionally did, like traditionally was done offshore drilling, narrow or shallow offshore drilling, you had a pretty stable rig. Well, what's happening now is we've kind of exploited those near shore resources and now we're going further offshore. And what this creates is a whole other set of problems, but essentially you have a rig that literally floats, and the costs of these can be sometimes phenomenal. It just kind of goes to show what we'll do to produce this oil. Upwards of $1.5 million a day can be spent to keep one of these operational. And consider that a typical land drilling rig can be operated daily by spending about $50,000 to $60,000 of the gas and oil money, or company's money. Now, these are called super deep wells that are drilled 2,000 in excess of 2,000 meters offshore, and those are becoming more and more common. But like I said before, the engineering feats to be able to extract that oil is quite amazing, I guess, and there's still a lot of room for it to improve. The last thing this author, VC Clesidis, brings up is a theory of abiotic hydrocarbon generation, which is basically a theory that even deeper underground than what we're traditionally drilling, there is hydrocarbons can form abiotically, which traditionally hydrocarbons form from layers of organic life forms being buried, pressure and heat and time, and they produce hydrocarbons. Well, this theory brings up the idea that trapped in the crust there is hydrogen and carbon dioxide, and in the presence of an iron catalyst, over time they can produce hydrocarbons without organic material. So basically he claims that there is a possibility that there's essentially a limitless supply of hydrocarbons down there if this proves to be true. There have been some thermodynamic models that say that it is possible to produce these hydrocarbons, but whether they're going to be a predictably reliable source is not true. It's not proven yet, I guess. So no gas and oil companies are really exploring this abiotic theory, because it does cost quite a bit to be able to run one of these operations. And it just goes to show what kind of extremes we're going to try to figure out how do we keep our thirst for oil quenched, I guess, as a world as a whole. And I just like to say that, yeah, there's a lot of room to go and a lot of places for this field to grow, but we probably aren't at our limit yet. Thank you.